My name is Rudra Vakela and I am from CSPIT CSE 2. My student ID is 24CS105 and my today's case study topic is quantum versus digital computing. Bits versus qubit, the ultimate battle. So first of all, we have a question. Why should you care? In now emerging days, computers are everywhere. In our phones, AI, gaming, banks, school, computer. Everywhere we find our computers. But digital computers have limits. They take too long for complex problems. Unlike a quantum computer, they are turbocharged in a brain, solving an impossible task in just a second. Example: imagine you are finding your friend in a giant stadium. Okay, with a digital computer, he will go and check every seat one by one. But quantum computer have a catch. He find them instantly because it took all seat at once. So it can easily find your friend at that 1 second. And now, from we start, what is a digital computing? So basically, we can understand it's a normal computer which work with bits like a 0 and 1. One step at a one, either 0 or 1. We can use in it our phones, AI, gaming, cyber security everywhere. Example: your laptop, your Instagram running in your phone, and Netflix suggestion system, which also runs in a binary code 0 and 1. It has a limitation. Slow down for a massive problem like a simulating galaxy. It is a giant task for any digital computer because it creates a binary data in 0 and 1, which is a massive, very massive. So our device cannot able to handle it, and that's why it become a slowdown. So now we have a what is a quantum computing. So quantum computing is basically an advanced computer that use qubits instead of bits for processing information. Unlike a digital computer, it have a qubit which can be a 0 and 1 or both at the same time. Okay. Quantum code. Okay. Quantum state code. And okay. Quantum state code. Entanglement. Two qubit can to be linked, so changing one instant affect other one, and quantum computer solve problem exponentially faster than a classic computers. Also, we have some challenges like a need extremely cold temperature for betterment of our quantum computer. Strangling and error prone. Small distribution ruin calculations. Expensive cost millions to build and maintain. Future used in AI, medicine, cryptography, and solving complex problems. Core difference between a digital and quantum computing. Digital computer use bits, while quantum computer use a qubit. Quantum computer can process multiple possibilities simultaneously. Qubit can to entangle means a change in a one instantly affect another, even miles apart. Digital computers solve problems step by step, while quantum computers solve them all at once. Quantum computer is like having an infinite parallel universe solving the same problem at once. Not about being a faster, but it's about solving a problem that a classical computer simply can't. So next topic is superposition and the magic of qubits. Superposition. A qubit is a both 0 and 1 at the same time. Example, like a spinning a coin, it's both heads and tails until it stops. Why is this so powerful? Exponentially computing power. Because it can calculate all possibility at once. Problem. Superposition collapse when it's observed. Like when you stop a spinning coil. It may be heads or it may be tail. You can't predict it right at that point. Entanglement, spooky action at a distance. Entanglement means two qubits talk even if were miles apart. Example, if two quantum particles are entangled, changing one instantly change the other, even across the galaxies. Why it is why is this useful? Quantum communication, unhackable internet. Means if we one thing change, other will adjust itself according to that. Quantum teleportation, faster data transfer, and Einstein called it spooky action at the distance. Real life application of digital computing, the power of limitless innovation. In everyday, our phones, laptops, smart cars, AI, all is a real life application of digital computing. Data processing, like a cloud storage and real life application of digital computing. The power of limitless innovation. Everyday life, phone, laptop, smart cars, AI assistant, everything is a application of digital computing. Data processing, like in cloud storage, cybersecurity, and banking. Medical imaging. In that section, we have X-rays and MRI scans. Example: your phone can process Google search queries in a millisecond, while real-life application of quantum computing, balancing processes and while while real-life application of quantum computing, balancing process progress while real-life application of quantum computing. Balancing progress and responsibility, cryptography, breaking and making ultra secure encryption, AI and machine learning, training models at a quantum speed, drug discovery, simulating a molecules for new medicines. Example: Google Sycamore computer chip solved a problem in 2000 milliseconds that would take a fastest supercomputer 10,000 years. Why is quantum so hard to build? Qubits are fragile, near about a 0 degree they bond. Error are common. Even a small noise can disrupt calculation. Super expensive, millions of dollars per machine. How quantum helps AI and machine learning? Quantum can train AI model 1000x faster. Example: AI prediction climate change the 100x more accuracy. Google's quantum AI already training advanced neural networks. Challenges of quantum computing. First of all, we have a frigidity. Quantums are extremely sensitive and can lose information easily. Temperature requirement need near absolute zero to function. Error rates. Even a small disturbance can generate a big calculation error. Cost. Building of quantum computing cost millions of dollars and requires a specialization lab. હવે કરું છું. Why can't we use quantum computers everywhere? Still in experimental stage, not ready for a daily use like a digital computers. Limited application, mostly used in research and high level problem solving. Difficult to scale. Increase the number of qubits without error is a huge challenge. Expensive and complex. Need a special cooling and quantum hardware. Can't fit in your pocket yet. Why quantum computing will challenge the world? Cybersecurity, unbreakable encryption and hacking defense. Medicine, fastest drug discovery and DNA analysis. AI and machine learning, super fast processing for a complex AI model. Climate science, better weather prediction and environmental modeling. Example: IBM and Google are already using quantum for scientific breakthroughs. Quantum computing versus digital computing. Who wins? Digital computers are great for everyday tasks, gaming, and general processing. Quantum computers best for solving a massive and complex problem quickly. Reality. They will work together. Quantum for a deep problem solving and digital for a daily tasks. Real life companies working on a quantum computing. First of all, we have a Google achieved quantum supremacy in 2019. IBM offer a cloud-based access of quantum processors. Microsoft developing quantum software and hardware. D-Wave specialized in quantum optimization problems. One quantum computer fact. A 3000 qubit quantum computer could process more data than there are atoms in a universe. Quantum teleportation is real. It has been tested with particles over a long distance. Quantum computers don't think like a human. They computers all possibilities at once. The future of quantum computing. More stable qubits. Scientists are finding a way to reduce the errors. Quantum internet, unhackable and ultra-secure communication. More commercial use. Industries like finance, medicine, and AI will start using a quantum computing. Example: China has already built a quantum satellite for ultra-secure communication. Common myths about a quantum computing. Myth. Quantum computer will replace a classic computer. Truth. They will work together for a different task. Myth. Quantum computer are just a faster version of normal computer. True. Truth. They solve different type of problem, not just a speed. Summary and final thoughts. Digital computer are a best for daily tasks. Quantum computer best for solving complex and scientific encryption problem. They will work together, not replace each other. The future is a quantum. Stay ready for a revolution. Thank you. I am Rudra Vagela and here is my contact detail. If you have a query, you can contact me. The only limit is the imagination.